previous lectures I've given on the same topic. So here's how you might define a function to count the clubs in a hand using recursion in this example. The number of clubs in the empty hand is 0. The number of clubs in a hand that looks like this starts with a card C. Well, it depends. If the suit of the card is equal to clubs, then it's 1 plus the number of clubs in the rest of the hand. Otherwise, it's just the number of clubs in the rest of the hand. Okay? So everybody's kind of seen that kind of definition before. You've maybe written some yourself. Or maybe you did it using list comprehensions. That's perfectly okay as well. Right? Everybody on the same page? Great. Now, let's suppose you say, okay, I've got a function for counting the number of clubs. But now the rules of the game have changed a bit, or I'm playing a slightly different game. I'm going to need one of these for spades. Say, okay, that's easy. I know how to do it for clubs, so I can definitely do it pretty quickly for spades. So then you start saying, well, this is how we're going to do it. It's dead easy. We just take this definition here, and I copy it. What? And I paste it over here. Right, of course. Oh, very good. Exactly right. So what do you do instead? Well, let me start by writing this out, and then we'll fix it. So spades, blah, blah, blah. Spades, blah, count spades. Count spades. Excellent. Sort of. All right. So that's fine. We've got two definitions. They're great. And then maybe we can do a couple more. Hey, why not? You could, but you've all realized that, no, you shouldn't be doing this. This is bad. In your future programming careers, every time you do this kind of cut and paste, I want you to vision me looking over your shoulder and just going. Okay, so what do you do instead? Well, if you take these two definitions, what we're going to do is we're going to say, well, what's different between these two? There's not much that's different. They do more or less the same thing. But we have to ask the question, what is different between them? And the only thing that's different between them, apart from the name, of course we use a different name for each of them, but the essential difference is that one uses clubs here and the other one uses spades. So the way that we fix this ugly programming is to make a more general function that can do the job of both of these guys. And how do we do that? Well, we think about the thing that's different between the two of them, and we make that an extra parameter to the function, right? So instead, we write a function called, let's say, count. And the count function is different because it takes as a first argument, it doesn't have to be the first argument, but let's do it the first argument, an extra parameter saying which suit is it we're going to count. Okay? So then we take the hand and return how many there were. So we're going to write a more general guy, and the more general guy, then we can do a legitimate cut and paste, the good cut and paste, which is the one we use when we're going to fix this ugly programming. We're going to call it count. We're going to add the extra parameter, which is the suit S, as a parameter. And we're going to, instead of checking for spades, we check whether it's equal to the suit we're looking for. We have to remember to add in the extra suit parameter in the recursive calls as well. So then we have a more general function. Let me try and tidy this up a bit so it doesn't look quite so ugly. We have a more general function, which means instead of count spades, we could define count spades for some hand H to be count spades in the hand. Okay? And we do the same for count clubs. So if we really needed a name for the function, which we probably don't, but if we really did, then we could define it in this way. Okay? So everybody's seen that process, this kind of sometimes called refactoring in software engineering. You refactor your code to sort of make it more reusable, make it more general, make it nicer to read, and so on. Okay? So the recipe there was identify the things which are different and make those into a parameter. The things that were different were a suit, so we added an extra parameter, which was a suit. Okay? All right. So let's take another example, or another couple of examples, that are nothing to do with the lab 2 data type. Here's a function for adding together all the numbers in a list of numbers. Okay? So the sum of the things in the empty list is 0, because 0 is the unit element of addition. If we want to add up all the things in a non-empty list, you take the first number in the list and add it to what you get by recursively summing the rest of the elements in the list. So this corresponds to the sum function in the prelude. That's why I call it sum prime, because it already exists. Okay? Nothing unusual about that function. Okay? Now let's suppose I want to define the product function. Okay? Well, product is kind of similar. Let me call it prod. The product of the empty list is, if I want to multiply all the elements in the empty list, it's the unit element of multiplication. It's 1. The product of a non-empty list, well, I should call it n because it's a number of some sort and a list of numbers, is going to be n multiplied by the product of the rest of the list. Now you see these are pretty similar. I could have done cut and paste here. Let's take another example that has nothing to do with numbers. The concat function is a function that takes a list of lists and joins them all together into one big list. So if you concat the list containing 1, 2 as the first element, the second element is 3, 4, and the third element is, I don't know, empty list. This will create one list that joins all of those things together. So it kind of flattens a list. Flattens a list of lists into one list. So how would you find that? Well, if there's no lists to join together, then you get the empty set, the empty list. Otherwise, if we have a list of x's on the front of a list of x's, then we take the first list and we join it to the result of recursively concatenating the rest of the listies. Okay? So that's how you join a bunch of lists together. But what did you notice about all of those? They're all doing the sort of same thing. Okay? So let's apply our method for making one function which does the job of all of those by identifying what is different between these three functions. Where do they differ? Well, they don't differ in just one place, they differ in 2 places. The 2 places are the base case and the operator you use to combine the elements of a list. So in this example, the base case is 0 and the combining operator is plus. In this case, the base case is 1 and the combining operator is multiply. So there are 2 things which are different between these examples, but everything else is the same. So if we're going to make a more general function that does the job of all of these, it will need 2 extra parameters. The function is normally called fold. It's called fold R because it folds together the elements of a list in a certain order from left to right, roughly, or right to left. Oh, anyway, doesn't matter. So it's called fold R. I'll call it fold R prime. It takes 2 extra parameters, okay, compared to these 3 functions, which take just 1 parameter. The 2 extra parameters will be, what is the combining function, f, and what is the base case, b. So here the combining function is the addition operator, and the base case is 0. Okay? And if we have an empty list, then the answer will be this one over here, the empty list. If we have something which is, let me cut and paste that line there, and this line here, okay, it's not gonna, I'm gonna have to change a bunch of things. Let's call it X and X's. Then what we're going to do, get rid of that. What we're going to do is combine the element X and the result of the recursive call, fold R prime with the same function, the same base case, but the smaller list X's. We're going to combine these two together using the combining function f. Now maybe it looks a little bit different to what I wrote up here. I can make it look more similar if I write f in infix as an operator by putting it into backticks. So I'm combining x and the recursive call using f. But I'm not going to do that. I'll just write f of x. So f is a 2-argument function. So what this function does here is does the job of all of these three functions, but in a more general way. So if I want to add up all the elements of a list, I can use fold R prime. What's the function I need to use? It's the plus function. What's the base case? It's 0. Oh. Oh. What have I got wrong? Yes, it's not the empty list. Correct.
Fold R prime also already exists.
That's not a problem. So I said that the base case, when we get the empty list, we give the base case. The base case is B, not the empty list. So sorry about that confusion. So B is the base case, F is the combining function. Let's see if this one works. Okay, does what we expect. If we alternatively take one of the earlier examples, concat, what is concat? Well, it's just fold R with the plus plus operator, joining lists together operator, and the base case is the empty list. So we have a single function which can do all the different combining jobs you can think of. If you have any way you want to combine elements together in a list, you can do that by using the fold R function, by giving it the right combining function and the right base case, and it will fold them together. Now, a little bit of fun you can have is that, in fact, fold R is an extremely powerful function. It can do a huge number of things that you probably never imagined it could do, if you provide it with the right functions. So one little game is to think of a function which works uniformly over the elements of a list, and think how you can define it with fold. For example, reversing a list. You can do that with a fold. Think about what function you might need to give it to reverse a list. You could even take the head of a list using fold. Be a crazy thing to do, but you can do it. So fold is actually very powerful, although sometimes tricky to use because you've got to think of the right function to feed it. Okay? So what was different between this example and the previous example? Well, it wasn't very much. The only difference was the thing that was different between these three cases was included a function, the plus function or the multiply function. And because it was a function, when we generalized these three patterns, what we got back was a higher order function, a function that has a function as one of its arguments. Okay? So that's where higher order functions come from. They give us a way of writing general patterns of computation, general reusable functions. They arise very naturally by recognizing what is similar between different definitions and converting those similarities into a single function. And in order to do that, we often need functions as arguments. Any questions? Okay. So one way of thinking of fold intuitively is that if you have an operator and a base case, you can kind of think of it as replace every cons in the list with the operator and replace the nil at the end of the list with the base case. That's one visual way of thinking of fold R. And that helps you understand fold L, which is a tail recursive version of fold, which instead of building in this shape, it builds by starting with the base case and adding on the elements by combining in the elements one at a time. So fold L is slightly different and sometimes can be more efficient. All right, here's a string I'm going to use in a few examples. So it has no significance other than I just needed an example of a string which was several lines long. So as this string is built from several lines, and I join them all together using the unlines function. So let's use that example. So if I write out song 2, what does it look like? Well, when you join all these lines of text together, you get one big long line of text where the new line character is inserted after every line. Okay? And if you wanted that to be printed out nicely on the screen, you'd have to use the IO function put str learn. And then that will actually then display those new line characters just by actually causing it to display on the next line. But that's not important. What's important is we know roughly what unlines does. It puts a new line character at the end of every line and joins all those lines together. Right? So let's use fold R to define it. Unlines prime will take a string, and what will it do with the string? Well, we're going to join all the lines together. But what function do we use to join them together? Well, if we just use the plus plus operator, then it's not going to do the right job. We want something a bit like plus plus, but we want something which adds this new line in between when it joins them together. Okay? And we don't have that function. So what do? Well, we can just define that function. Okay? So this is the simplest way of feeding, well, the second simplest way of feeding a higher order function. This is a higher order function, and we're going to feed it with an argument. When we looked at the examples here, the function that we fed it with already existed. So we didn't have to create it. So that was easy. It was easy to feed. We took one off the shelf. Okay? But sometimes you can't always take the food off the shelf. Sometimes you have to cook it yourself. Okay? So in this case, we need to cook a function ourselves. So I'm going to call that function join lines. I haven't defined it yet. I've just given it a name. I'm going to say it's called join lines. So I'm going to use a join lines function to join the lines together. When I get to the end of the list, I'll just need the empty string, or the empty list, doesn't really matter. I'll write it as an empty string. It's the same thing. So that's the definition of unlines, providing I define the right join lines function. So what is the join lines function going to do? Let's make it a local definition. Join lines will join two lines together, string 1 and string 2. And it will join them together a bit like that, but it needs to put a new line character in between. So we can write that in a pretty way by making a small string with a new line character in it and wedging that in between these two guys. So there's my join lines function. So by folding, combining all the lines of the list together using join lines and ending with the empty list, then I should get the unlines function that I was hoping for. Let's try it out. I should be able to do unlines my version. Something's not quite right. Oh, it doesn't apply to a single. Obviously, I have to convert this thing into lines first. So I have to go back from the song text into its lines, and then I can unline it again. I'm going around in circles. And so it seems to do the same job as the original unlines. I suppose I could have tested it by just changing this to unlines prime and just going song 2. Yeah. Okay. Any questions? Okay, so that was an example of using the higher order function in the case when we didn't have the right combining function already made. And how did we solve it in this case? Well, we just defined it. I made it a local definition because it's only really interesting inside this function. Nobody else needs to know about join lines. This is like a little private function used by this guy.